Good morning, students. In today's class also we are going to see some more problems in projectile motion. Okay. Next one. A body of mass m thrown horizontally with velocity v from the top of tower of height h touches the level ground at a distance of 250 meters from the foot of the tower. Okay. A body of mass 2m, this is the second body, thrown horizontally with velocity v by 2 from the top of tower of height 4h will touch the level ground at a distance of x from the foot of the tower. Okay. The value of x is, okay, we are having two bodies here. First body is with mass m and second body is with mass 2m. Okay. Then with velocity, the first body is thrown with velocity from top of a tower height. Okay, it is thrown horizontally with v velocity. Okay, from tower of height h. From tower of height h, it is thrown with a velocity v. It touches the ground at a distance of 250 meters. Okay. Now, the second body, it is also thrown horizontally with velocity v by 2. From top of the tower of height 4h. The height is 4h. Touch the level ground at the distance x. Okay, then we have to find x. Okay. Now, if you see this one, the equation of path of the projectile which is thrown horizontally from top of tower is given by y is equal to gx square by 2u square. It is independent of m. There is no need to consider this mass. Okay, then we simply write y is proportional to x square by u square. G is constant, 2 is constant. Y is proportional to x square by u square. Or y1 by y2 is equal to x1 square by x2 square into u2 square by u1 square. Or simply x2 is equal to x1 u2 by u1. All these are having squares. If they come to that side, then root of y2 by y1. We simply get 250 into u2 is v2 by 2 by v. Root of y2 is 4h by h. 4. We are going to get 250. Okay, a simple calculation here. Okay, so it is going to fall at the same distance. Okay. Okay, next problem. From the top of tower of height 40 meter, a ball is projected upwards with a speed of 20 meter per second at an angle of elevation of 30 degrees. Then the ratio of total time taken by the ball to hit the ground to the time taken for ball to come to same level as top of tower is. Okay, a ball is thrown with a velocity of 20 meter per second from a tower of height 40 meter at an angle 30 degrees. You can be top of a tower, the ball is thrown like this. Then we have to calculate the ratio of total time taken to hit the ground. If it is thrown from here, it is going to hit the ground like this. To the time taken for the ball to come to the same height. If it is thrown from here, it is going to come to the same height. Okay, this time to this time. Okay, total time taken to come to the horizontal position. Okay, then h is given as height of the tower 40 meter. Okay, velocity 20 and theta is given as 30 degrees. This is the time to hit the ground. This is time to come to the horizontal position. Okay, for these times of flight, there is no need to consider horizontal component. We just consider vertical components. That is, we take the vertical component. Okay, it is u sin theta. That is 20 into sin 30 is 10 meter per second. That is, here our u is 10 meter per second. Then we apply this formula. Y is equal to ut plus half at square. Okay, here a is minus g. Okay, then for time to hit the ground, the height is h. That's why the displacement becomes minus h. Then applying this one, minus 40 is equal to, this is minus 40 is equal to 10 g is minus 10 into t square. Okay, then simplifying this equation, this is 5 tg square minus 10 tg minus 40. Then t square minus 2 cancelling out with 5, we get tg square minus 2tg minus 8. That is writing this one as minus 4 plus 2. Okay, minus 4tg plus 2g. We get tg is equal to 4 seconds. The other one is t is equal to minus 2 is extraneous rule. Okay, for that is we get tg as 4 seconds. For th, y becomes 0. Then applying the same formula, 0 is equal to 10 th instead of tg, we get th here minus 5 th square. Then th is equal to th cancels out. Then 5t is equal to 10 5 th is equal to 10. We get th is equal to 2 seconds. Therefore, this ratio becomes 4:2. That is 2:1. Okay. Okay, next problem is two tall buildings are 30 meters apart. The speed with which a bar must be thrown horizontally from a window 150 meters above the ground in one building so that it enters a window 27.5 meters from the ground in the other building is. They are throwing a ball from one building to other building from certain height. Okay, it is from a height of 150 and it has to enter into a window which is at 27.5 meter in the other building. Okay, and the distance between the buildings is they are separated by 30 meters. Height of the window in the first building is 150. Height of the window in the second building is 27.5. What is the velocity so that it can reach to this window? Okay, that is horizontal. That is nothing but x distance is given 30 meters. Y distance becomes the difference between these heights 150 minus 27.5. That is 122.5 meters. Then we apply this one. Y is equal to, that is the path of projectile for a horizontally thrown body from certain height. Y is equal to gx square by 2u square. That is u square is equal to gx square by 2y. Then u becomes this x into root of g by 2y. Then x is 30 meter. X is 30 meter. G we take that one as 10. Then y becomes 122.5. That is 10 by 2 into 122.5. That is 10 by 1 into 2 into 122.5, 250. Then 0 0 gets cancelled. We get 5 meter, 1 by 5. 30 into 1 by 5. We get 6 meter per second. See the next problem. A body of mass m is projected horizontally with a velocity v from the top of tower of height h and it reaches the ground at a distance x from the foot of the tower. If a second body of mass 2m is projected horizontally from the top of a tower of height 2h, it reaches the ground at a distance 2x from the foot of the tower. The horizontal velocity of the second body is. Okay, we have to calculate the horizontal velocity of the second body. Okay, first see of mass, first body mass is m. Okay, it is horizontally projected with the velocity u1 is equal to v from the top of tower height is taken as h. Then it reaches the ground at a distance x. Okay, then x1 becomes a. If the second body of mass 2m, mass is 2m, horizontally from the top of a tower of height 2h, it reaches the ground at a distance of 2x. Then we have to calculate the horizontal velocity of the second body. Then we are having this one, y is equal to gx square by 2u square, where u is horizontal velocity. Okay, it is independent of m. Therefore, we can straight away write that y is proportional to x square by u square. Here y is nothing but h. h1 by h2 is equal to, okay, x1 square by x2 square into u2 square by u1 square, or simply writing for u square becomes, u becomes u1 into x2 minus, all these are having square, therefore u2 becomes u1 into x2 by x1, the root of h1 by h2. u1 is given as v, then x2, it is 2x, x1 is x, then h1 is h, h2 is 2h, then we get x gets cancelled, h gets cancelled, 2 by root 2 or root 2, that is v root 2. Okay, the velocity is v root 2. See the next problem. A projectile is projected under gravity with velocity root 2 ag from a point at a height h above the level plane at an angle theta to it. Okay. The maximum range or on the ground is, okay, a particle is projected under gravity with velocity 2 ag from a point at a height. From a certain height it is projected. Okay. At an angle theta. The maximum range on the ground is, from a certain height it is thrown like this. What is the maximum range on the ground? Okay. Then velocity is given as root of 2 ag, height is given, then theta is given as theta. We have to find maximum range. Okay. We know this equation for the projectile. Okay. Then y is equal to tan theta into x minus g into 2u square cos square theta into x square. Here, as it is hitting the ground, y is equal to minus h, x is equal to, we just take that one as range. Okay. Later we will apply the maximum condition to that one. Okay. We have to find our maximum. Okay. Then this becomes, for the given situation, y becomes minus h and x is equal to r. Then we take minus h is equal to tan theta into r minus g into 2 u square becomes 2ag. 2ag, g gets cancelled, cos square theta. Then we simplify, rearrange this one. Okay. First cancelling out g, we get 4a 1 by cos is secant square r square. We bring this term to this side, minus tan theta into r to this side, minus h is equal to 0. We can write, first we multiply with 4a, 4a we get. Then secant square as 1 plus tan square theta. You know this identity. Then we take this, we write the expression for tan theta term. Okay, we write the equation for tan square theta. R square tan square theta, this plus r square, it goes here, it is a constant, minus 4a r tan theta, okay, plus this r square minus 4ah. This is the equation in for tan square. Then for tan theta to be real, okay, if it want to be real, the condition is b square should be greater than or equal to 4ac in ax square plus bx plus c is equal to 0. For this equation, this is the condition. For this equation, we write this b square. B square is 16 a square r square should be greater than or equal to 4 into a r square into c. R square minus 4ah. Okay, r square minus 4ah. Then this becomes 4 fourths r square gets cancelled. 4a square is greater than or equal to r square minus 4ah. Then we concentrate on this one. Okay, or we can write r square minus 4ah is less than or equal to 4a, or r square is less than or equal to 4a square plus 4ah. Then here it is less than or equal to, that is the maximum value is this one. Therefore, our maximum square is equal to 4a square plus 4ah. That is our maximum becomes root of 4a square plus 4ah. Bringing out 2 and taking a common, we get 2 into root of a into a plus h. It is 2 into root a into a plus h. This is how we are going to get the conditions are left, that is our maximum condition, okay, or its value.